Hello, my name is Marcy, and today I will be going over how to find the number of diagonals for a polygon. So I'm going to start by showing how to find the number of diagonals for a square or a parallelogram, like what I have drawn over here on the left-hand side. So how I constructed this square was I just made 4 points, selected all of the points, and constructed segments that connected each one. So the definition of a diagonal is a line segment linking two non-adjacent vertices. So my first diagonal for this square that I'm going to draw starts at vertice A, which is right here, and it is going to go to vertice C, as you can see by the green dash line. So why it goes to vertice C is because that is the only non-adjacent vertice of this square for vertice A. So B and D B and D are adjacent to vertice A, so they cannot have a diagonal to that one. And same thing for B. The diagonal for B goes from vertice B down to D. It cannot go from C to A because those are both adjacent vertices to B. Next, I'd like to show how to do one for a pentagon, which has 5 sides. So let me move this. Alright. Let's try and draw some diagonals from point E. So I would ask students to make a guess to see where they would put the diagonals. Would it go to F, G, H, or I? So I'd have them give me some guesses, and then we would draw the diagonals. So as you can see, the diagonals go from E to G and E to H. They cannot go from point E to F or E to I, because once again, those are adjacent vertices to E. Same thing for point F. I would ask them where they think the diagonals would go and why. Just like that. And as you can see, it goes from F to I and F to H. And for point G, it goes from G to I, but the vertice also goes from, the diagonal also goes from G to E. I would have students follow along with me as I'm doing this in front of the class, and then for a later assignment, I would have them try and figure out the number of diagonals on their own. Next, I would show them an octagon. The octagon gets a little bit more complicated. There's a lot more diagonals going on. So I'm going to start over at point D, which is down here on the bottom. I'm going to draw the diagonals. As you can see, there's 5 diagonals, and they all go to non-adjacent vertices. So that's why C and E are left out from this one. I'm going to now draw my diagonals from vertice E. Same thing, there's still 5 diagonals to the 5 non-adjacent vertices. For point F, or for vertice F, there's still 5, but this one right here isn't green because when you count the vertices, you only count the ones that are new. Since we already counted it for vertice D, we're not going to count it again for vertice F. For G, we have 3 new diagonals, and our 2 that we've already created from G to D and G to E. For diagonals from J, we have 2 new ones, and we still have those 3 that were previously created to get a total of 5 vertices coming from J. And from vertice A, We still have 5 diagonals. This new one right here that I'm going over, that's the new one, but then we still have 4 other ones that were previously created. And same thing from vertex B, we still have 5 diagonals. And the number of diagonals formed from D is 5. The number of diagonals formed from point E is also 5. The number of diagonals formed from point F is 4. Although there is one more, we don't have to count it since it was already counted in the diagonals formed by point D. The number of diagonals from G is 3. Same thing, we don't count the other ones since they've already been accounted for. From point J, there's 2 new ones formed, and the last diagonal formed is from point A. So a sample problem, or what I would hope students learn from this lesson, I would want them to be able to find the formula or figure out the formula for finding the number of diagonals of a polygon. And what I would hope they would find is that the formula is n times n minus 3 divided by 2. And n represents the number of sides of the polygon. So for the square, there is 4 sides. So 4 times 4 minus 3 is 1. So 4 times 1 is 1. Divided by 2 is 2. And we got there was 2 diagonals. So that worked out. Same thing if you were to do that with a pentagon, which had 5 sides. You would realize that there is only 5 diagonals. And for the octagon, we found that there was 20 diagonals. A sample problem that I might give the students is I would ask them how many diagonals a 20gon has. Students should be able to use the formula that they have previously discovered, which is n times n minus 3, all divided by 2. And some sample work that the students might show is 20 times 20 minus 3 over 2, which then becomes 20 times 17 divided by 2, which then becomes 340 divided by 2 to get a final answer of 140 diagonals. Wow, that is a lot. And a further question that I might have students investigate to see if this works is, does a triangle have diagonals? And if not, why is that true? And what I'd hope that they would realize from this is that a triangle cannot have any diagonals because there are no non-adjacent angles from any of the vertices. And thank you for listening.